Welcome to a lesson with Dr. Powell. Let's take a look at an example where we have a boat being hauled in to a dock. Suppose we have, suppose this is 3 feet from here to here, and I'm going to call that R. Suppose that this is that the boat, that the, what we want is the rate of the rope being pulled. So how much rope is being pulled. So dr dt, suppose it's being pulled at a constant rate of maybe, let's do 1 foot per second. Okay, 1 foot per second. And perhaps this makes an angle right here. And we would like to know what is d theta dt at the instant when r is equal to 5. Okay, so let's figure that out. So automatically for values, we might even just kind of be thinking a little bit in our heads. At the time when r is 5, it's a 3, 4, 5 triangle. Just assume that's 4. That might be useful. But let's actually keep everything variable for a minute. As we come up with the relationships, we need to come up with the relationship between r and theta, where we keep these as variables. And then we can use that to come up with the relationship between an equation between dr dt and d theta dt. So let's do this. All right. Well, if we take 3 times, 3 times the secant, because r is not 5 right here, not right now, because we're going to assume that it's variable first. So if we take 3 times the secant of theta, that's going to be equal to r. Now, we could see that in various ways. One way of seeing it, you could always just think the secant of an angle times the adjacent is always the hypotenuse. That's one way of thinking about it. Or you could think about the secant of the angle as being the hypotenuse over the adjacent. But however way you look at it, this is one nice way of looking at it. Okay, now from here, we can, since we have an equation that relates r and theta, we can take a derivative with respect to t, thinking of r and theta both as functions of t. We'll use a chain rule right here because this is secant of theta, so multiplication by d theta dt in the end. We take a derivative secant times tangent, and theta is plugged in there. Okay, so that's kind of what we're going to be looking at when we take a derivative on this side. We can just write that down. 3 secant theta, where the 3 stays multiplied, tangent theta, d theta dt. And on this side should be fairly clear. It's just dr dt. Taking derivative of everything with respect to t. Now, at this instant, when r is 5, we should actually know how to compute secant and tangent since we have the sides. So we should know that the secant is going to be 5/3 at this moment. The tangent should be 4/3, and we have a 3 there. And we are interested to know what d theta dt is, and dr dt we're given to be is just 1. Okay, so we cancel that out. We get 20/3 times that. Take a reciprocal and multiply over. It'd be 3/20 is equal to d theta dt. What are the units? Well, working with seconds and theta, well, we assumed it was in radians to be able to have this derivative formula, so it's radians per second. So this would be 3/20 radians per second. Thanks for watching.